Okay, we're going to cover section 2.5 in a little bit different way. You're going to watch this video. It'll be just like I'm explaining things up at the board, and hopefully this works out. You can pause the video, replay it, whatever you need to, and maybe get through things a little bit quicker if you catch on. So anyway, we're going to go with the starter questions here. This is section 2.5. It's on combining functions, and we're just going to start off with two simple functions. So we're going to start off with the identity function, just y equals x. So everybody knows that's, line goes through the origin, has a slope of 1. If we needed to, I mean, you could always back up and do what you learned how to do a long time ago, make a little xy table. But this goes through 0, 0, and 1, 1, and 2, 2, and negative 2, 2. So we're going to connect these, and we've got this line here. Okay, put an arrow on both ends because it extends forever in both directions. And then we've got y equals cosine x. And we know how to graph that. We know that starts at 0, 1. But then we've got to take a look at these tick marks. These tick marks are 1 unit apart. So we want to make sure that we do these on the same scale. So this would go through, well, the first time it hits the x-axis is at about pi half. So that's about 1.5. So we're going to have a point here. It hits negative 1 at about 3.14. So that's going to be about there. It goes through the x-axis on the way back up at 3 pi halves. So 3 pi halves is about 4.7 if you'll remember. So we've got 1, 2, 3, 4, about 4.7 right there. So I'm just going to make the graph look something like this. So we've got this piece. Now it continues to do the same thing on this side. So I'm going to stop right there. And then we'd have to have it look something like this. Okay? So two fairly simple graphs, one from algebra, one from trigonometry, but we're pretty familiar with how that works. Okay, now let's take a look at this particular section. In this one, we're supposed to draw a combination of a couple different functions. So we've got y equals x plus cosine x. Now, in this section, it's going to be enough if you draw a good rough sketch with a couple of points labeled. Okay, it doesn't have to be perfect. All it has to have is just the right idea. So if you had to take a guess at what we get when we take a line, like y equal x, and combine it with a wave function like cosine x, if you had to take a guess at what we get when we put those together, you might guess, well, a line plus a wave would be a wavy line, and that's what it's going to turn out to be. So we're going to get a couple points here, and what you want to keep in mind is this is a fairly complicated function to graph, but we can always graph something using an XY table. So I'm going to switch colors here. So this is going to be, whoops, we're going to put a little XY table. So we're going to have X and Y. And remember, Y is X plus cosine X. So as you're picking points to evaluate this function, it would be best if you picked ones that are easy to evaluate in the more difficult of the two. So we've got x and we've got cosine x. So by far this is the more complicated one. So we're going to pick things that are easy to evaluate there, like over here at 0 and at pi halves and at pi. And 2 or 3 points is going to be plenty in order to figure this out. So let's go ahead and plug a couple in. So let's plug in 0. If you plug in a 0, you get 0 out of x plus the cosine of 0. Well, the cosine of 0 is 1, so that's 1. And what I'd like you to notice is the function value here is 0, the function value here is 1, and you literally just add this function value to that function value, and you get this function value right here. So let's do another one. Let's do pi halves. So we're going to have, let's see, this is going to be pi halves plus the cosine of pi halves. Oops. Yeah, pi halves. So pi halves. So cosine of pi halves is 0. So this is pi halves plus 0, so that's just pi halves. So that's about 1.5 and 1.5. So we're going to go over 1.5 and up 1.5. Oops, I forgot to graph this little guy right here. Okay, so we've got that one. And then let's throw pi in there. So if we put pi in there, we get pi plus the cosine of pi. So that's pi. Cosine of pi is negative 1. So this is going to be pi minus 1, which is weird, but we can graph that. That would be about 3.14, and then up about 2.14. So that's going to be about right there. Okay, now, this has got some sort of curve to it, some sort of wave to it, so it looks something like this. And this part goes over here, something like that. Now, what I want you to take note of is, if we drew kind of like a center line to this, It would look something like that. Now that's not perfect, but you can see it kind of looks like the line that we had up here for y equal x, and it's got this cosine curve added to it. So we've got a line here and a wave here, so we get a wavy line. And as long as we graph this blue graph right here and we label a couple points, we're in good shape. So this is 0.01, this is pi halves, comma, pi halves. This point right here would be pi, comma, pi minus 1. And that's good enough. If you wanted to label another point over here, not that one. Better get that right. We'd probably label this point right here, and this would be negative pi halves, comma, pi halves. And you can verify that by plugging that in. So if we take a line and a wave and we get a wavy line, what do you think happens when we take a square root function, so top half of a sideways parabola, and we put that together with a negative sign function? So this is a negative sign, so it would actually start at 0 and go like this. Now remember, we don't have any values for the square root function for negatives. We can't plug a negative in there, so we wouldn't worry about any negative coordinates, x coordinates for the sine function. So we've got this square root function here, and we're going to add a wave to it. So you might guess we get a wavy square root function. Okay, and that is what we're going to get, but let's pick a couple of points to graph here. So let's make a little xy table, and let's just get 2 this time. Let's plug in 0, because that's easy to plug into both of them. Square root of 0 is 0, so we get a 0 out of this, and the sine of 0 is 0. Okay? And then let's plug in another one. Let's plug in pi, because pi is really easy to plug in. That's going to be the square root of pi minus the sine of pi, and the sine of pi is 0, so you're just going to get a square root of pi. So we get 0, 0, and then pi, that's about 3.14, and then the square root of 3, somewhere around right there. So it does go up, just like we'd expect. Now the question is, if we've got this square root function, and that's kind of look like that, and then we shouldn't, maybe not right there, maybe a little bit higher than that, because it's got to go through here, here, and then 4, 2. So it's going to go something like this. That looks a little bit better. All right. Now, the question here is, does the graph kind of wave up and down like this, or does it wave down like this? So does it start by going up or start by going down? Well, we could kind of reason our way to a decent guess by looking at this and saying, well, we've got this square root graph, and then we subtract these values right here. So my guess is that it goes down. Okay, so I'm going to guess that it does something like, oops, we've got to go through that point right there. Better back up here. So it goes something like this. Okay, now that's good enough if there's a test question like this. If you labeled 0, 0 and you graphed pi, comma, what was this? Square root of pi, that's going to be good enough. Now on both of these, let's back up and let's check and see. So grab your calculator. Oops, wrong one. Let's see right here. There we go. And let's see where the calculator went. There it is. Okay, there we go. And let's put this in there and let's see what we get. So we're going to turn this on. And I've already got this in here, so I put in x plus cosine x. And then we want to look at this window right here. Probably, well, let's see, this goes about 5 either direction and then 2 or 3 in this direction. So a good candidate for a window here would be, if we hit zoom, let's go zoom decimal. So we're going to hit zoom 4. And then let's look at that graph. Not too bad, that's what we've got here, okay? So I'm going to zoom out. Let's take a look at zoom standard. Not too bad. Okay. Now I'm going to zoom back in and let's take a look at something else. Let's take a look at, there's our graph. Okay, now I'm going to do this. I'm going to go to y equals. I'm going to put in, remember we kind of said what the center line of this would be? let's go ahead and put in an x, and I'm going to hop over here. If you didn't know your calculator could do this, we can actually have it graph in dots. So I've got those dots there. So I'm going to hit graph, and there we are. It doesn't look like they're dots because it's kind of connected, but there we go. That's kind of looks like the midline. Not perfect, but similar idea. All right. So let's back up here and let's put this function in. So we're going to put in the square root of x, and then we're going to subtract the sine of x. Now, if you weren't able to get that last graph to look right, it may be that you had your calculator in degree mode, and since you can't plug degrees into a square root function or a linear function like y equal x, you got to have this in radian mode in order for this to work, okay? And I'm going to clear this off. And then we'll go with that small window again. We'll go with the decimal window. Not too shabby. Let's hit trace. We've got 0, 0 here, and then let's type in, so we've got pi here, let's type in pi, and let's see where we end up. 3.14 and 1.77, which is the square root of pi, okay? Decent estimate there. So that looks pretty good, and it looks like we had it go down like it should. So as long as it looks roughly like a square root graph, and we've got that wave to it, then we're good shape. Label a couple points and we're in business. So I'm going to do this. We're going to change the window and we're going to go from 0, let's go to 10, and we don't get any negative values out, so let's go 0, 3.1 will work. Let's maybe go 4 just so we can see this. Looks pretty good there. Now it's kind of got that shape. We could zoom out even more, but I want to do this. Let's go in here and let's type in the square root function. Now let's graph. And look at that. Look how that looks kind of like the midline for this. If we were to make this even bigger, so let's change the window. Let's go to 100 in the x direction, and let's go up to 10. You might want to think about why our guess is for a max of 10, but let's take a look at that. There it is, cycling back and forth. And look at that midline running through there. Pretty cool, huh? Okay, so good evidence so far that if we take a square root graph and then subtract a wave function, we get a wavy square root graph. Again, decent picture here. Doesn't have to be perfect. All you have to do is get roughly the right shape and label a couple points. So let's take a look at this right here. And what we want to consider on this one is when you take the two of these shapes, now these are defined for all reals, so we're going to take those and add them together. The exponential function gets big really, really, really fast. So if we add a wave to an exponential function, we're going to get some sort of wavy exponential function. And what I want you to look at is look how small these function values are here. It's got a horizontal asymptote of y equals 0. So this, if we add zeros to these guys right here, it's really going to look like a sine function over on this side. And then if we take these points and add them together, now these are really big over here. So adding or subtracting, remember the biggest this gets is 1 and the smallest it gets is -1. That's not going to make a huge difference here. Okay, but let's pick a couple points. And a good point to plug in would always be 0. So if you plug in a 0, you get a 1 out of this, you get a 0 out of that. So it goes through 0, 1. Okay. So if this problem were on the test, I wouldn't argue with you. As long as you had an exponential function that was kind of wavy looking, that went through 1, I'd be fine with that. So we're going to make it do something like this. Okay, that's pretty ugly. Okay, something like that. All right, that cleans it up and looks nice. So it goes through 0, 1. And then let's pick another point to plug in. Now on this one, there's nothing good to do here. Let's plug in a pi. So that's going to be e to the pi. My gosh, that's a nasty number. And then we're going to add sine of pi. But wait a minute, sine of pi is just 0. So we don't even need to write that. Okay, so that's maybe not as bad as we were thinking. Let's label another point here. That's going to be pi comma e to the pi. Now, just to double check, let's grab that calculator again. And let's type our functions in. Now, this is exponential base e and then we're going to add the sine of x. Now, hopefully we get a graph that looks something like this. And let's graph e to the x just for the heck of it, because that should be our, what did we call that again? That's kind of like our midline, okay? Now, let's get a decent picture here. So let's hit zoom 4 and see what we get. Well, there's a wave right there. It does go through the right point, but look at this. Gosh, you can't really tell what's going on there. Okay, there's the center again, so we're in good shape there. That looks okay. Let's hit zoom 6. Let's go in that -10 to 10 window. That looks a heck of a lot like a sine function. And gosh, you can hardly tell the difference between the graphs over here. But over here, it looks a lot like a sine function. And that has to do with the size of each one of those function values. Over here, sine is -1 to 1. And the exponential base e is just essentially a 0. Further we go out here, the bigger those exponential numbers get, so adding or subtracting a 1 doesn't make much of a difference. But this would be good here. Let's trace 0, 1. Type in a pi. Let's see, e to the pi, 23.1. Let's just double check that. Let's go to the home screen. We'll clear that off. And we'll hit e to the pi. Now we said it was 23, right? Well, there we go. Okay, so that's good enough. Again, on the test, all you need to do is just get close. Doesn't have to be perfect. Take a good stab at what it would be, and then label a couple points. So let's do this one real quick. Let's not drag this out too much. There's the reciprocal function. Cosine, that pi is going to speed it up, so it's going to cycle pretty fast. Now let's think about this. If you take this, it's actually a hyperbola. If you take this nice gentle curve right here and you add a wave to it, it's going to make a wavy curve there. But these values, like an exponential, get really big. These get really small. So out near the end, it's going to wave up and down, but we're probably not going to see much right here. Same thing on this end, it's going to wave up and down. So let's pick a couple points. Notice you can't plug in 0. So let's do x equals pi, and let's do negative pi. And I'd be satisfied if you did 2 of these. So, well, you know what? I mean, take a look at this. Gosh, this is easy. If you just plug in numbers, just plain old whole numbers or integer numbers. So let's not plug in pi's. We don't have to do that anymore. Look, there's already a pi there. So let's plug in 1 and -1. So this would be 1 over 1. That's a 1. Plus cosine of pi. When you plug in a 1, you get cosine of pi. Cosine of pi is -1. So you end up with 0. So this goes through 1, 0. When you plug in a -1, you get a -1 out of this, and cosine of negative pi, that's going to be -1, so that's going to be -2. So -1, -2, okay? So we're going to get a graph that looks something like this, and we're going to go like this, something like that. And as long as you label 2 points, you're just fine. So we're going to graph 1, 0, -1, -2. And let's check and see. Okay. Let's see, what have we got here? 1 divided by x plus cosine, and then we've got this pi x. And we'll graph. Hopefully we picked a decent window. Well, that looks pretty good there. Not bad at all. Let's hit trace and type in a 1. We got 0, that looks good, and type in a -1, and we got -2, okay? Again, looks like that cosine curve out here because the 1 over x doesn't add or subtract very much, and then it's really steep there. We get big function values out of this guy, so the cosine just adds or subtracts 1 at the very most, so that doesn't change the shape very much. This next one, that's a bit more difficult because cosine does this. Sine, well, that's a 2 sine x, so it's going to start at 0, it's going to go up to 2, so it's going to be taller than that other one. Now, I'll be honest with you, guessing what this is going to look like when we take a wave plus a tall wave. we're going to get a really interesting looking function. All I want you to do on something like this is let's plot some points. So let's plug in a 0. 0 here, you get a 1. 0 here, you get a 0. So it goes through 0, 1. So we've got at least 1 point. If you plug in a pi halves, let's see, cosine of pi halves is 0. Sine of pi halves is 1. So this would be 2. Okay, let's do pi. At pi, let's see, cosine of pi, that's going to be 0. That's going to be sine, that's going to, well, let's see, that's going to be negative 1. And then that's going to be 0. So we're going to have negative 1 here. And then let's do 3 pi halves. Let's see, cosine of 3 pi halves, that is 0. And sine of 3 pi halves, that's negative 1. So that's going to be negative 2. So we go up to 2. To negative 1 by the time we get to pi, to negative 2 by the time we get to 3 pi halves. So we're going to get something that looks like this. And all you'd need to do is just label a couple points. This isn't a very precise section. Really tough to graph these if you don't have a calculator. So pi halves comma 2. Might be good to label one of these down here with the negatives, 3 pi halves comma negative 2. Okay, and that would be good enough. And you can check that on your, well, let's go ahead and check it right now. So we get cosine x plus 2 sine x. And let's go a fairly small window. So let's hit zoom 4. Not bad so far. Look at that shape there. Gosh, it just looks like a big wave function, right? Hard to tell the difference between that and a phase shift of a sine or a cosine curve that has an amplitude of 2, but pretty good there. That's all that would be expected. And if I were going to give you one like this, I'd probably have you double check it on a calculator anyway. Okay, let's go back here and let's finish this up and see what we've learned here. On number 39, it says match the equation with the graph. So we've got y equals negative x plus cosine 0.5x. Okay, that 0.5x is going to change the period. It's going to make the period, well, let's see, that's a 0.5. You'd think that would horizontally shrink it. It actually horizontally stretches it. It changes the period. So our b is 1/2. Our period would be 2 pi divided by 1/2. Our period is going to be 4 pi. So this is a really stretched out cosine curve. Okay, it takes a really long time for it to make that. But we've got a line with a slope of -1. And we've got this cosine graph that's been really stretched out. Okay, looks like that. Well, a line with a slope of -1 plus a curve that's been really stretched out is probably going to be something, well, we can probably rule out B and we can rule out D. Probably neither one of those. Okay, this might be a parabola plus a wave. That might be some weird trig function. Who knows what that is? But we've got a slope of -1. Well, look at the two of these. They're both lines plus a wave, but this one has two issues wrong with it. One, it's got a positive slope, and the other thing is, look how fast this is oscillating back and forth. Okay, that's a really fast wave, not a really slow wave, so it'd have to be that. If that makes sense, we're in pretty good shape. That's really all you'd have to do to cover this section. All right. Okay, that's it for section 2.5. That's actually it for chapter 2. You should take a look at these right here. These would be really good to practice for the quiz that we're going to have on chapter 2. Remember, chapter 2 covered sine, cosine functions, those graphs. We also talked about tangent, cotangent, cosecant, secant graphs, phase shifts, all that sort of thing. You really need to be able to graph something like this or like this. A really good thing to practice for the quiz that's coming up. So please make sure you do that. All right, thank you very much. If you need to watch this again, feel free to rewind, and I'll be around to answer questions, so come see me if you need help.